Welcome back. This is the second day for section 5.3. We are looking at the sum and difference for tangents, and there's two ways you can look at it. You can learn the formula for tangents, or you can think of the tangent of u plus v being the sine of u plus v divided by the cosine of u plus v. So if you have the sine and cosine formulas memorized from yesterday, you may want to use that version. There are times where we have to. For example, with our first example here, number 5, we are looking at the tangent of theta minus 3 pi over 2. And if you think about where you are with 3 pi over 2, we're down here. Ordered pair would be 0, negative 1. And so if we were finding the tangent of 3 pi over 2, we would take our y over x, so negative 1 over 0, and we see that it is undefined. So since we can't substitute tangents in here where we need them, we're going to have to think in terms of sines and cosines instead. All right, so looking at our formulas again. For the tangent of u plus v, we have the tangent of u plus the tangent of v. So notice the top, the sign doesn't change. But on the bottom, it does. So if we have a plus here, we're going to have a plus here, but we're going to have a minus there. And it's just the opposite for the second one here. If we have a minus, then the top matches it, and the bottom goes to the opposite. Okay? All right, so let's try number 5. It says, prove the reduction formula that the tangent of theta minus 3 pi over 2 is equivalent to opposite of cotangent of theta. All right, so we're going to start with saying the tangent of theta minus 3 pi over 2 is the same as the sine of theta minus 3 pi over 2 divided by the cosine of theta minus 3 pi over 2. So we're just thinking of tangent as sine over cosine. All right, now let's use our sine and cosine formulas. Our sine formula for the difference of two angles is going to be sine of the first times cosine of the second. And then because it's a sine, the sign stays the same. So it's a minus, we're going to keep a minus. And then we have cosine of the first times the sine of the second. Okay. On the bottom, we have cosine of theta minus 3 pi over 2. And cosine is cosine, cosine. So cosine of the first, cosine of the second. And for cosines, that we have opposite signs, so we have a plus here. And then it's sine first and sine of second. All right, now we need to do a lot of simplifying here. The thetas we can't do much about right now, but all of the 3 pi over 2's we can replace. So this is sine theta times cosine of 3 pi over 2. And the cosine, or the x-coordinate at 3 pi over 2, is 0. Then we have minus cosine of theta, and the sine of 3 pi over 2 is negative 1. On the bottom, we have cosine of theta times cosine of 3 pi over 2, which is 0 again, plus sine of theta times sine of 3 pi over 2, which is negative 1 again. And when we simplify this, sine theta times 0 is 0. Cosine theta times 0 is 0. Negative 1 times negative cosine theta is cosine theta. On the bottom, negative 1 times sine theta is negative sine theta. And cosine divided by sine is cotangent. So this becomes negative cotangent theta, which is what we were trying to prove. All right, our second one deals with a ratio of 5 pi over 12. So we're looking at radian measure here. We need to somehow write this as the sum or difference of two angles. And if you think back to what we did yesterday, or go back to your notes from yesterday where we had all of our 12ths marked out. Let's see if we can find that here. All right, so we were trying to come up with 5 pi over 12. And we came up with this option of saying that is 2/3 pi minus 1/4 pi. So that is an option. There are others. Let's start with that one. Okay, so let's think of the tangent of 5 pi over 12 as the tangent of 2/3 pi minus pi over 4. All right, so let's think about our angles. We need to get our tangents. Pi over 4 is here, and we have ordered pair of root 2 over 2, root 2 over 2. So the tangent of pi over 4 would just be 1. All right. If we are looking at 2/3 pi, coordinates over here are -1/2 and root 3 over 2. So tangent would be tangent of 2/3 pi is going to be root 3 over 2 divided by -1/2, which becomes negative root 3. Okay, so now we can substitute our values in. Because tangent is defined here for both angles, we really don't have to convert this into sines and cosines. We can go ahead and use our tangent version. It is a tangent of a difference, so we are going to be using this formula on the bottom here. Okay, so the tangent of u minus v is the tangent of u minus the tangent of v divided by 1 plus the product of them. All right, so let's fill in our angles. So this is going to be the tangent of 2/3 pi minus the tangent of pi over 4 divided by 1 plus the product of those. Okay, and over on the right-hand side, we've already figured out what the tangents are for each of those. So I'm just going to do some substitution. We said the tangent of 2/3 pi is negative root 3 minus the tangent of pi over 4, which is 1. On the bottom, we have 1 plus the product of those two values. So negative root 3 times 1. Now, how do we simplify something like this? Top, we've got negative root 3 minus 1. On the bottom, 1 plus a negative root 3. So let's just write that as 1 minus root 3. Okay, and we have to do something in terms of rationalizing this denominator. We don't want to leave radicals in the denominator. And we rationalize denominators when they're conjugates, like when they're complex like this, 1 minus root 3, by using its conjugate, 1 plus root 3. And whatever we multiply to the bottom, we have to multiply to the numerator as well. All right, so let's do some foiling. We have negative root 3 times 1. Outsides, we have negative root 3 times a positive root 3. That gives us a negative root 9, or just negative 3. We have insides a negative 1. And last term, we have a negative root 3. All right, on the bottom, foiling, 1 times 1 is 1. Outsides, we get a positive root 3, insides a negative root 3, so those will cancel out. And then our last term again, a negative root 3 times a positive root 3 is a negative root 9, or just negative 3. All right, simplifying. We have a negative 3 and a negative 1, which gives us negative 4. We have a negative root 3 and another negative root 3, which gives us negative 2 root 3. On the bottom, these two are going to cancel out, and we have 1 minus 3, or negative 2. And then we can simplify that. Negative 4 divided by negative 2 is 2. Negative 2 root 3 divided by negative 2 is a positive root 3. And that would be our final answer. All right, I am going to show you another option for this one. just so you can see that there are various ways we can break up that 5/12 pi. So let's look at saying the tangent of 5 pi over 12, and let's think of a different way of getting 5/12. All right. To get 5/12, we could add 2/12 and 3/12. And we know both of those. 2/12 is just pi over 6. And 3/12 would be 1/4, so pi over 4. Okay, so that's just another option. We could have split it up that way. So we would end up with the tangent of pi over 6 plus the tangent of pi over 4 divided by 1 minus the tangent of pi over 6 times the tangent of pi over 4. And we already know that the tangent of pi over 4 is 1, so that's going to make this pretty easy. The tangent of pi over 6, our ordered pair for pi over 6 is root 3 over 2, 1/2. So tangent is going to be 1/2 divided by root 3 over 2. The 2's drop out, we get 1 over root 3. Rationalized, that would be root 3 over 3. All right, so let's replace tangent of pi over 6 with a root 3 over 3. Our denominator, we have 1 minus our tangent of pi over 6, root 3 over 3, times tangent of pi over 4, which is 1. All right, so I wanted to show you this one just because it looks a little bit messier. We have the square root of 3 over 3 plus 1 in the top half, and we have 1 minus the square root of 3 over 3 in the bottom half. And to clean this up, the first thing we want to do is let's get rid of the fractions both on the top and the bottom. Let's get that to be not so complex. So let's think in terms of thirds. I'm going to multiply this one by 3 over 3. I'm just multiplying by a 1, but I'm getting a 3 as a common denominator there. So I end up with root 3 plus 3 all over a 3. For the bottom part, if I times this one by 3 over 3, I end up with 3 over 3. Sorry, we'll do it like this. 3 minus root 3 all over a plane 3. And then to divide, we multiply by reciprocal, which means this 3 here and this 3 here are going to cancel. So we end up with root 3 plus 3 over 3 minus root 3. And then again, we would have to rationalize that like we did in the last problem. And we multiply by the conjugate of the bottom piece. So 3 minus root 3's conjugate would be 3 plus root 3. And then we again have to do some foiling. So we end up with 3 root 3. We end up with a root 3 times a root 3, which is just a plain 3. Inside we get 9. And last term we get 3 root 3. On the bottom half, first terms give us a 9. Insides and outsides are going to cancel out again. And then our last term is just a minus 3. All right, so simplifying, the denominator is a 6. On the top, we have 12 plus 3 root 3 plus 3 root 3 would be 6 root 3. And again, we can simplify, divide everything by 6, and we get 2 plus root 3, which is the same answer we had on the other one. So I'm just showing you that there are a couple different options when you look at trying to split up something like a 5 pi over 12. All right, so different ways of doing that can lead to different processes, but still the same final answer. All right, so yesterday we had you working on this assignment, and I said to skip all the ones involving tangent. So today you need to go back and do all the tangent ones. Okay.